Hi, this is Jacobs here, physics teacher at Naperville North, and I'm here to do a tutorial on how to solve for the displacement of an object by using a velocity graph. We're going to be using the same graphs that we did in the previous tutorial video where we solved for acceleration, but now we're going to be using them to solve for displacement. The first thing you need to know is that displacement is the area on the velocity graph. And area, by area, I mean between the line and the x-axis. Okay. When we had a velocity graph first semester, in the first semester, we had constant velocity. So we had lines that were flat, like above zero or below zero. I'll do a negative velocity. Okay. And we used this was in meters per second. This was in seconds. And we said, okay, we can get the meters traveled. We can get the displacement from this graph by finding the area of this rectangle. Let's say this was -3 meters per second and 5 seconds. We would do -3 meters per second times 5 seconds. Seconds in the denominator here and in the numerator here cancel out, and I'm left with just meters. And it is a vector with a negative direction. This is saying displacement is not, I just went 15 meters, but I went 15 meters in the negative direction to the left. This semester, we're also going to have area on the velocity graph. The difference is it's not going to be always a rectangle anymore. For example, on this velocity graph, if I take the area between the line and the x-axis, it looks like this. Okay. Shaded in like that. This is also going to be a negative displacement once again, because it's below zero. And this is technically a trapezoid. Now you can use the area of a trapezoid formula. I prefer just to take any trapezoid and split it into a rectangle and a triangle. Okay. This rectangle does matter. Sometimes people say, like, why do I need to figure out that area? It's because an object that's moving at -2 meters per second, it starts at, like, that's already moving fast. And this is speeding up in the negative direction. That's fast, that will cover more meters than if an object just started at 0 and sped up, and it would only be a triangle. You do need to find the area of the rectangle and the triangle and add them together. So let's do that. This rectangle was 6 seconds wide and -2 meters per second tall. So that's going to be a displacement of -12 meters. The triangle, draw it like it is on the graph, like this. Wow. Like this, there we go. The base of the triangle is 6 seconds wide. The height of the triangle is not -6 because it started at -2 and went to -6. So the height of this triangle is -4 meters per second. And a triangle isn't base times height, it's 1/2 times base times height. So 1/2 times 6 times -4. So -24 times 1/2 is, this is also -12. So then the total displacement is going to be -24 meters. That meters shows up on the position graph. Okay, we've been drawing the shapes of the position graph. This is a speeding up in the negative direction. So this would be going down, but speeding up, getting steeper. So something like this. Okay. And now I know that it's moving -24 meters. So let's say, I'll just put some numbers on here. Let's say it started at 20 meters. Now I know it ends at -4 meters. Because its overall displacement is 24 meters in the negative direction. The acceleration graph has nothing to do with the displacement, really. The acceleration graph is the slope of the velocity graph, and that's from the previous tutorial video. So that's a negative slope. That's my straight line. Okay, let's do one more practice problem. Problem 2, my velocity graph here, I'm going to find the displacement, which by the way is delta x. It's the symbol for displacement, it means change in position. It's going to be this between the line and the x-axis. So once again, it's a rectangle and a triangle. This is 2 seconds wide and 4 meters per second tall. So that's going to be 8 meters positive. And then this triangle here, sometimes people are like, oh, that's a negative slope. It's like, well, yeah, the acceleration is negative during that part, but that doesn't mean the area is negative. The area is above 0. That's still a positive direction of motion. That's still going to be a positive number of meters. So we've got 4 meters per second. And this time, this base of the triangle is not 6 seconds. It's only 4 seconds because it's from 2 to 6. So this is going to be 1/2 times base times height. 4 times 4 is 16 times 1/2. Well, this is interesting. That ends up being exactly the same amount. That's not always the case, that these two amounts are the same that you're adding together. But now my total displacement is positive 16 meters. And again, if I were to I can put that now on my position graph. I can say, hey, guess what? It was going straight, constant velocity. Then it was slowing down, still moving in the positive direction. It started at 0, it ended at 16 meters. Again, if I started down here, it doesn't really matter where I start the position graph. What matters is that I have a displacement of 16. So that would be up here at 12 meters. Because that's a positive 16 displacement. Hopefully that helps you find displacement from a velocity graph.